A detail drawing is a drawing that contains all the information required for a specific part. There are many different ways a part can come into existence, including casting, machining, welding, purchasing a part, or even modifying an existing part. As such, there are also a variety of detail drawings depending on the way in which a part is generated. A casting drawing is a type of detail drawing for parts made by casting or molding. The material for the part is typically called out in the material block, although it can sometimes be found in the notes section. A critical part of any configuration control process is adequate identification of manufactured parts. Most casting have their part numbers permanently cast into the part. The dimensions on a casting drawing are what the foundry or manufacturer uses to make a pattern or mold and are the final cast dimensions of the part. Other information that may be included on a casting drawing are mold lines, datum plane references, and even information on how to best remove the part from the mold. A machine drawing details all the information required to take raw material and turn it into a finished part. The machining tolerances, material, finishes, etc. are all shown on the detail drawing. Machine drawings are detail drawings that require machining to create the end product. They can be developed using a cast part as the original material. In this drawing, the casting from the last example was used as the starting material. This machining drawing will remove material from the original casting and add the finishes required to produce a final product with its own unique part number. Only the dimensions necessary to convert the original cast part into the new part are required. The casting dimensions are not shown. Detail drawings can build on one another. For instance, a machinist could take an existing part and add or remove material to change its configuration. This type of drawing is called a modification drawing. Modification drawings delineate changes to existing items. As with a machine drawing made from a cast, modification drawings are created to add, remove, or rework details that result in a new part. Only the dimensions or other information required to alter the part into its new configuration are documented. Modification drawings also incorporate mandatory changes. For example, safety, reliability, or application extension into existing delivered equipment. This type of drawing can also be referred to as a make-from drawing. Another type of detail drawing is the purchase part or procurement drawing. This type of drawing details all the information required to buy a stock part off the shelf. This type of detail drawing typically only shows information useful to the purchaser to detail the performance or configuration of the item required. These characteristics are typically called the form, fit, and function of the part. It's up to the manufacturer to develop detail machine or casting drawings that conform to the purchase part drawing requirements. Pattern development drawings detail the dimensions of a part when it is flat, as well as the final shape it takes, typically by bending or folding. Pattern development drawings are frequently used where sheet metal, fabric and leather, tubing, plastic, or cardboard is the raw material. Pattern drawings show not only the dimensions of the unfolded item, but also detail where the fold lines are. Weldment drawings are a unique form of detail drawings. Weldments occur when multiple pieces are welded together to form a final item. Weldments are not assemblies, due to the fact that their component parts are not stocked or sold separately, have no use as standalone items, and are not detailed on separate drawings. Weldment drawings can also be called inseparable assembly drawings. Welding symbols that indicate the length, type, and other information about the weld are shown in the field of the drawing to indicate the location of the welds. An assembly drawing shows two or more separable parts joined to form a final product. The bill of material for an assembly drawing lists all the parts required to make up the assembly. Each part is given an item number, which is then referenced in the field of the drawing with a balloon for ease of location. Older drawings sometimes list the zone location in lieu of a balloon. Assembly drawings can show exploded views or section views. This drawing utilizes a section view to better identify each item in the assembly and to give an interior view of the part. Section lines are used to indicate the portions of the assembly that have been cut away. There are few, if any, hidden lines in an assembly drawing. Only the dimensions required to fully assemble the part or to be used as references are shown. In many cases, the order of assembly may be given in the notes. Subassembly drawings are made of two or more separable items that join to form a subassembly that is then used on a higher level assembly. Subassembly drawings are useful for smaller assemblies that may go on multiple end products, such as a hydraulic valve that goes on many different tractors. One of the differences between an assembly and subassembly is that a subassembly typically has the use on or next higher assembly called out either in the title block or in the notes section. Working assembly drawings combine detailed drawings and assembly drawings. These drawings contain enough information to both create the subcomponents and assemble the finished product. Working assembly drawings show dimensions where required, as well as balloon identifiers to indicate each separate component part of the assembly. Working assembly drawings are ideal for smaller, simpler assemblies. Since they combine both detail and assembly characteristics, they can become complex very quickly. A diagram assembly drawing shows installation of equipment using symbols and is often made in pictorial form. Diagram assembly drawings are typically used to depict wiring, piping, and other systems where scale models and dimensions are not required. Each part on a diagram assembly is indicated by a picture. Exploded assembly drawings are not very common in a set of production drawings. They are best utilized to show both the individual pieces of the assembly as well as the order in which they are assembled. Exploded assembly drawings are typically used in maintenance manuals, parts catalogs, or other information given to the general public. With the advent of computer-aided design, or CAD, it has become easier than ever to generate exploded view drawings. A full set of production drawings may contain detail, assembly, subassembly, working assembly, and diagram drawings that are all used to depict the final product.